All right. Good morning, or indeed good afternoon, everyone. Welcome to this webinar on Snowflake and Telematics. My name's John Bratton. I'm a sales director here at Snowflake in London. Today, I'm delighted to be joined by telematics expert and consultant Lewis Clark. Lewis has a very impressive career in telematics, telecoms, IT systems across fixed, mobile, satellite technologies in some very large global blue chip businesses such as Jaguar Land Rover, Honeywell, Ericsson, and Marconi. The agenda for today's webinar will start with an overview of Snowflake and how we can handle telematics data so easily. And after that overview, I'll hand over to Lewis, who's going to talk about the telematics landscape and provide some thought leadership around the data underpinning it. And we'll then conclude the webinar with some Q&A showing you how to get access to Snowflake should you wish to test it out for yourselves. So let's start with our introduction to Snowflake. Snowflake's mission is to enable every organization to be data-driven, and we work with companies across all industries from insurance to logistics, software platform providers to tier one automotive manufacturers, airlines to construction. The list really goes on. And as we support our customers in their journey to become more data-driven, I've started to notice some themes across the data supply chain. And a prominent one is why we're here today, and that's telematics. So we've got attendees on this webinar from all of the industries that I just mentioned, using telematics data in different ways. But we know something for sure, and that's because of the volume and the structure and the pace of update and the number of users that need to get value from it. Lots of companies are working way harder than they need to when it comes to using the telematics data. So why is it so difficult in today's database technology? If we look at the various different aspects here, first of all, data-driven analytics have become mission critical for pretty much all of today's organizations. And as a result, tens or hundreds or thousands of users need to access data in reports or dashboards. And of course, the users just expect fast and up-to-date results. But most database technology makes it quite hard and certainly very costly to scale the resources to handle these peaks. Data should be flowing in constantly from devices, updating at the same time as people analyzing it. So it's really hard to satisfy this concurrency versus performance needs of different data types with different user groups, and at the same time driving towards real-time data access. Now, making your analytics systems highly available is another expensive, complex, and time-consuming task, especially with GDPR and compliance requirements. And finally, with most database technology, it can become quite a burden on IT teams to maintain the software and to ensure it's up to date and compliant, that it's got all the latest security patches. So with Snowflake, how is this different? First of all, Snowflake was designed from the ground up to avoid all of the shortcomings that I just discussed. And it provides this single place for all of your data, be that device data or business apps or customer data. And all the users in your organization across all departments can collaborate within one single common place with very secure access. Secondly, Snowflake has a unique architecture that's built to take advantage of the unlimited storage and compute power that's available in the cloud. And we can scale compute and storage independently of one another. And as a result, you can support virtually unlimited data volumes and concurrency levels without any slowdown. Snowflake operates as a software as a service platform. So you don't have to worry about installing or managing software, provisioning storage, indexing, applying patches, security, just anything else associated with running a data platform. So with a single place for all your data, Snowflake will allow you to share all this data within your organization and across departments, but also to securely share it across other organizations as well. And all of this is made possible with Snowflake's unique multi-cluster shared data architecture. It's really a game changer, and there's just nothing else like it out there on the market right now. So if we take a look at how it works, so I mentioned this unique architecture and how we started with the flexibility of cloud storage. So this gives you the ability to store unlimited amounts of semi-structured and structured data in the same place. And we handle both these data types right out the box. So telematics and IoT data is really easy just from the get-go. And then on top of storage, we built services and this SQL engine that you need to be able to run your data warehouses without any management. So Snowflake handles all the optimization and scalability and security for you. And you can see here in this slide how the different warehouses, which provide the compute power for different analytics processes, access all the shared data within the cloud storage. And you can create those virtual warehouses at any time, either using SQL commands in Snowflake or through the Snowflake user interface. So if you've got different workloads with different needs, for example, you've got telematics devices updating data, and you've got ETL, you've got data science teams running algorithms, you've got execs running reports, and then you've also got customers using that data set to do analysis on their own telematics usage. You can separate the warehouses for those workloads, and by doing that, you're providing workload isolation, so they can all happen at the same time without causing any slowdown or fighting for resources from one another. And you can even create a multi-cluster warehouse that will scale automatically to really high numbers of concurrent queries and then auto-scale back down after that peak. And you can turn off any of these data warehouses automatically, instantly, anytime. And because you only pay for what you actually use, the cost of running Snowflake can be much lower than many other databases. So all of this is delivered as software as a service, and so we manage all the stack, and it's highly available and highly secure. As of today, we've got more than 2,000 customer proof points. So companies built off data like Red Bull F1, Nielsen, Sony, Deliveroo, Strava, Fitbit, Netflix, the list goes on, and they're all using Snowflake, trusting their data and analytics to this platform. And you'll probably see a few other familiar names on that slide. Spearon in the US, they use the tagline, the vehicle intelligence company, and they provide a large range of services built around telematics. Before Snowflake, they were really struggling to even load all of their semi-structured data because there were so many changing attributes within the data. And then there was this large payload volume of data from each device. And then further down the chain, they had real limitations on compute for querying the data, and their storage costs were surging. So they needed an advanced data management infrastructure that will enable them to provide real-time business insights to their 40,000 customers. And now with Snowflake, they've got a zero maintenance platform. They handle data from 4 million connected vehicles, generating 1 billion data events per month, and racking up a total of over 360 billion driving miles. Our customers' success definitely wouldn't be possible without this rich ecosystem of partners that support them with various aspects of Snowflake. And in the slide here, you can see an overview of some of the partners that we work with on other parts of the stack, like ETL and business intelligence tools. There's system integrators and partners who build all sorts of services around Snowflake. So it's an incredibly flexible platform. Okay, and with that, I would like to hand over to Lewis.
Thank you, John. Good morning, everyone. So I'm going to take you through a whistle-stop tour of the contents below. So a sort of telematics landscape, past, present, and future, some commercial vehicle and telematics overview and some use cases. Economic value of data, so kind of the big picture. And I'm going to talk about how much data we're talking about, some data definitions, and then some conclusions. So if we just recap on telematics and where it came from, it's been around for about 40 years now, and some of the French government officials produced a report, which was the basis for defining the French telecoms policy at the time, which then went on to an open platform preceding the internet. So we're largely looking at data over telecommunications networks. So we look at the last 20 years or so. We had the first vehicle commercial telematics introduced by General Motors, and that's sort of expanded over time as the supporting telecommunications speeds have entered the marketplace and ecosystem. So from 2G, 3G in the early 2000s, 4G another 10 years later, and we're just obviously launching 5G now, which allows more data, more use cases, more capabilities. And I guess most recently and significant is the introduction of things like eCall, mandated by the European Union, which uses GPS location, it looks at airbag status, and it contacts first responders. So things like that are driving up the propagation of telematics in commercial and light vehicles. They have also in parallel been fitted to commercial vehicles in the aftermarket sector for a long time as well. So some of the buzzwords and acronyms that you may have come across. CASE and ACEs are a common one, so depending on which way you order it. Connected, autonomous, shared, electrified. So mobility and sharing, interoperable. But effectively, connectivity enables all of those things. So electrification, electric vehicles like the Nissan Leaf had telematics from day one to monitor battery levels. Autonomous vehicles can't happen without connectivity, and you can't have mobility and shared vehicles without connectivity either. And also a fairly recent one is LEAD that I've come across to do with commercial vehicles. So although there's overlaps, there's obviously quite specific use cases in each type of market. So logistics being the key for commercial vehicles. But all of this is a kind of digital ecosystem and transition where we're utilizing connectivity, telematics. We've got more and more data and more use cases. This diagram I like, which kind of touches on all the kind of areas that are changing. So we've got expanding data sources enabled by high-speed data towers. We've got, well, obviously with the rollout of 5G, we can enable smart road infrastructure and V2X. V2X meaning vehicle to anything. Vehicle to infrastructure, V2I. We've obviously got GNSS satellite networks, GPS being the first one. We've also got other ones rolled out by Europe, China, Russia, for example. We've got high definition maps, which I like to describe to people are the invisible maps, because they're not navigation maps. They're the ones autonomous vehicles use to follow the road, the virtual road, and to take in data about their environment. We've got more and more software platforms, both on the vehicle and off the vehicle, largely migrated to the cloud, and all ideally talking to each other through APIs. And obviously, once we've got that huge amount of data, we want to bring in machine learning and analytics to make it far easier and efficient to utilize. So telematics and the Internet of Everything. So we've got IoT, IOV, Internet of Everything, lots of play on words. But in terms of vehicles connecting to whatever they need to connect to, each other or off-board systems, we've got predictions of 70% of all vehicle types being connected within 5 years. And I know for commercial vehicles, that's been happening from an aftermarket perspective. More and more OEMs on the customer vehicle side have been embedding telematics recently because of eCall and other systems. So often you'll see 90 to 100% achieved by 2020. But the fact is, it's not stopping, it's accelerating, and eventually we'll have pretty much everything connected in terms of transportation. So a bit on commercial vehicles and telematics. This slide I put together, not necessarily on commercial vehicles themselves, but business vehicles. So we look at the top 5 causes of breakdowns from the RAC, for example, and we think about the methods we might use in telematics and data. So, for instance, the biggest issue in terms of call-outs over 100,000 vehicles a year is to do with tyres, whether they're blowouts or wheel damage or other things. So tyre pressure monitoring systems have been around for a number of years, 20 plus years. They're fitted in premium vehicles many years ago, but then not always been connected. So now lots of both commercial vehicles and customer vehicles are being connected. You can monitor in real time the tyre pressure, and that has all kinds of operational benefits as well as safety. Most blowouts are caused by underinflation, so we've now got the technology and the data to do something about that. Flat batteries is the second highest call out. And now, as we go to electrification of vehicles, obviously from out of the box, those vehicles are monitored. Not necessarily exactly the same use of batteries, but a 12-volt battery, we could propagate the state of health and state of charge into an off-board system and monitor that, rather than just assuming failure is going to happen and then go out and handle it inefficiently. I mean, 50,000 call-outs, that's a lot of vehicles on the road, not very efficient use of vehicles. Fuel, don't really have an easy answer for putting the wrong fuel in, but if that does happen, you can use telematics to call out support vehicles much more quickly by pressing an overhead console button, for example, in an enabled vehicle. And then we move down to clutch problems, powertrain, and mechanical. Well, all of these kind of issues can start to be solved more efficiently using data from driver behavior, journey types. Obviously, you've got lots of starts and stops with a heavy loaded vehicle. That's going to put loading on your mechanical systems. We can start using remote monitoring of powertrain, mechanics and electricals, propagate that data over back-end systems. We can start building pictures of that, what's happening. We can use machine learning to then look at trends and start getting more intelligent about what we're doing. Okay, so if we look at the UK road haulage, some interesting facts and figures to focus the mind. So pretty much all food and agriculture products and all consumer products machinery is over the road network in the UK. So I would say how much of that is actually connected, I don't know myself, but lots and lots of it is already connected. And there's commercial vehicles over 3.5 tons, there's 500,000 of them. So from what I've said so far and what I will say, there's lots of opportunities to optimize those fleets using telematics and data. So some more data from Road Haulage Association on the approximate breakdown of costs for running commercial vehicle fleets. So labour, and this is a bit of a motive subject, but I know already in the US they've got a big shortfall of drivers, for example. So they're already looking to autonomy to introduce platooning of vehicles, for example, as a pragmatic and a technological solution. Fuel, obviously a lot of focus on reduction in fuel use. using telematics to optimize speed, routing, loading of vehicles, etc. Maintenance and tyres, I've already talked about TPMS and remote monitoring. In capital, well, actually, if we know what our fleet is doing and using through data and analytics, we should be able to reduce the downtime, or actually reduce the fleet size as well. And administration, we should be able to reduce the paperwork. Now, if you look at going to hire a vehicle at the moment, there's a lot of paperwork involved, or just the maintenance of administration. We can reduce that by having connected systems do a lot of that grunt work for us. Insurance and registration, well, I know there's a huge insurance telematics industry, which has been going for some years. UBI, user-based insurance. But obviously that industry is looking at where next on telematics, not just in driver behavior, but anything else where data and telematics can play into their field. So I just thought TPMS it's a well used use case for obvious reasons. Number one in the ROC's call out. And it has been around for a while. We've just looked at some of the statistics. It's quite interesting. So if we can monitor the 2% increase in fuel consumption based on lower tire pressures, that's a 25% reduction in wear. In increase in wear, so reduction in tire life. If we're talking of 500,000 commercial vehicles in the UK, it's not difficult to do the maths and realise where you can make massive savings. And we're not talking about revenue generation here. We're talking about cost reduction, cost avoidance. And we're also, if we look at tyre pressure relating to emissions, the number of accidents actually, with or without injury or fatalities, the numbers are very significant. And that's another reason why the EU mandated TPMS on vehicles recently, so in the last few years. And that's propagating to commercial vehicles as well. So I think in the US that came in 2007, and in the EU 2012. So largely the reasons for TPMS are, as I've said, monitoring tyre pressure, increasing safety, avoiding early leakage and doing something about that. Underinflation being the major issue. They also, not all of them, but most of them measure air temperature as well. So you probably know from your own vehicle, you get in on a cold morning, and on some vehicles, they say low pressure, but with complex algorithms, these devices can work that out. And obviously connecting those through telematics to the back end gives you lots of real-time data, particularly huge cost savings or cost avoidance in large fleets of vehicles, which might do 60,000 miles a week or something like that. So a bit on the economic value of data. So you've probably heard lots of buzzwords and abbreviations over the years. Data is new oil is one of the ones that's been bandied around a lot. That was 13 years ago. That got into everyone's inboxes and blogs and so forth. And then more recently than that, there was a TEDx talk by a journalist, actually, and I only came across him when a colleague lent me one of his publications when we were working on the data project. And I was interested in how we visualize data, because that's really how humans consume information more easily. So it's looking at the patterns that can be revealed in the data. And that's really what we're looking for, rather than just a lot of numbers and disconnected facts, as he puts it. And then more recently, only 3 years ago, we had this comparison between the oil-based businesses and world's most valuable companies. And in just 10 years, we've seen a massive transition to data-driven businesses and their value. Looking at it from another angle, we're not saying actually that all of those industries don't need data and telematics. They all do, but we're just saying that data is becoming much more of the economy. And then you've probably already seen this one as well, the most valuable resources. Dated only 2 years ago, and I think this has been, this is all sort of building momentum on data as the new oil or soil, whatever. But the point is, it's not going away. It's becoming more and more important in everything we do. And then we're only 1 year ago and a bit as GDPR came in, so we're now starting to govern and regulate it a lot more than we did before. So how much data? Well, I often see stats about how much data being collected from autonomous cars as being gigabytes per day or terabytes. Now, in reality, it's much less than that, but it is increasing. And if you think about the cost of data, it's going to make most people bankrupt if they're actually taking terabytes of data off a vehicle every day. But anyway, it's possible. So just a quick recap then on the last few years of data. So the first IBM hard drive was shipped some 70 years ago or so of 5 megs. And then even the first terabyte was quite a long time ago, relatively. And then the cloud itself, hosting lots of hard drives, in fact, has grown to 1 exabyte in 2013. And now we're talking about zettabytes by 2020. So just in that relatively short lifetime in, I guess, industry 3 and 4, we've seen a huge amount of data get generated and have to be stored. So what is the big data? Well, if we look at what Microsoft's thinking is, and we relate that to telematics, so we've got sensors, lots of those on connected vehicles. We've got spatial and GPS coordinates. That's what telematics is all about. Weather, for instance, lots of vehicles send or receive weather information, and that's all petabytes once you increase your fleet size. So what about the data sphere as a whole? So 3 interesting sets of figures here. I quite like the analogy that someone's come up with to turn 1 grain of rice into a byte of data. So that's equivalent of having a zettabyte fill the entire Pacific Ocean. So when we then talk about where we are on time in terms of zettabytes, we're about 40 zettabytes right now, and going to several times that in the next 5 years. So that's a huge amount. And then in that 5 years, half of it will be in the cloud. So that gives us an idea of the exponential growth of data. So data definition. So I was curious to know about the big data Vs and where they came from. In fact, it's nearly 20 years ago that one of the Gartner analysts came up with the first 3, volume, velocity, and variety. So if we work around clockwise, volumes, it talks about exabytes, zettabytes, and even larger amounts of data. And for our context, sensors, high-resolution sensors, lots of scalable infrastructure. And velocity, we're talking about in telematics, batch, near real-time, or streaming. We use all of those, whether it's streaming video or just journey data, which might be the end of that journey. And then if we go around to variety, we've got quite a lot of structured data, some semi-structured, some unstructured. So video off vehicles is unstructured. And then we go around to veracity, which is the 4th V. And we look at consistency, completeness, and so forth. And then 5, which is the most important one for most of us, the value of it. And I don't know why it took so long to realize that value was a key part. But we need to work out the cost of all of this collection and processing data versus the benefit. So like I said before, it's not all about revenue generation. A lot of it is down to cost avoidance, cost reduction. So a bit on the structured versus unstructured. So if we look at Gartner's view, for example, is that 80% of enterprises have unstructured data, so that's data that can't be displayed in rows, columns, rational databases, etc. And examples of images, video, audio, and so forth. And really, we want to take that unstructured data and make it structured, because it's easier to process, requires less storage, it's high value potentially. So a survey of organizations looking at how much unstructured data they've got, quite a lot. If you look at the highest there, it's 100 terabytes upwards. So that's definitely areas to be worked on. So some brief conclusions then of that whistle-stop tour, and you could go on, but I've just listed a few suggestions. So obviously a data strategy would be a great place to start, even if you don't have a chief data officer. A data strategy should be part of your overall business strategy, makes sense. And data must be treated like any other asset. And lots of business are starting to do that, but some really are not yet there. Maybe because they're not an IT-based business that might do something completely different. Understand the data you already have, what you've got, where it is, why you've got it, how much. All of those questions are important to ask. And define data governance and sharing. Well, obviously, some of that is being instilled on organizations anyway through EU regulation. But I think the important thing is to understand your maturity model. Either define your own or get someone to help you define it and understand where you are on that path to maturity. And turn dark and unstructured data into structured and actionable data, because that's how you're going to help realize the value. So then finally, recognize and achieve all of the 5 Vs, because just collecting a load of data and not doing anything with it is not going to realize any value. It's just going to cost a lot of money. Okay, thank you. That's the end of my short presentation.
Right. All right. Thanks, Lewis. Anyone feel free to type any questions into the Q&A box. We've got plenty of time to address anything there. There's 1 or 2 that have come in. Lewis, thank you. That was great. I particularly loved all the background and projections of future growth. I think the use cases for cost avoidance and monetization from telematics data are fascinating. And one customer I talked with described their telematics data as a pot of gold, and it's so easy to see why they call it that. So, yeah, very, very thought-provoking. Telematics is definitely an exciting space to be involved in, and many interesting opportunities and challenges ahead, which Snowflake can definitely help with. So let's just have a look at the Q&A section. We've got one here. I wonder, Lewis, if you might want to take a look at this question that's coming from Annie.
Mm-hmm. So what is the risk of access to connected car data in vehicle manufacturers if vehicle manufacturers introduce secure gateway and or reduce data via ODB2? The risk of access. And then the second part of the question, do the majority of telematic systems rely on dongles in ODB2? So I guess vehicle manufacturers really want to move away from ODB2 with their security hat on. And largely they don't use aftermarket devices. Some do for certain applications. So that basically that answers the question. It's embedded telematics, so it'll be an ECU within part of the electrical ecosystem of the vehicle. I know there's a plethora of ODB dongle telematics devices on the market. So I guess it's horses for courses. The aftermarket wants ODB because that's how they access the vehicle network. and vehicle OEMs see it as a security risk, and they'll try and design it out. What we do in the long term is subject to many discussions. I hope that answers the question, but we can take these offline anyway.
Annie and anybody else, if you're curious to know more about Snowflake or to speak with Lewis, please feel free to send me an email at john.bratton@snowflake.com. I'll just give it another moment to see if any more questions come in. And once I do that, if you're interested in taking out a trial, there's links on the website, or we can send you a link to help you get everything up and running. It doesn't look like any more questions in, so I think we are good. So thank you very much, Lewis, and thank you very much to everyone attended. We really hope you enjoyed this webinar.